Hello class, this is the third example of the generalized pigeonhole principle. So let's get straight into the third example. So a certain number of people had to be transported onto 5 different buses. At least one of the buses had 33 people on them. What range of total people were transported? Assume the number of people on each bus was kept to a minimum. Okay, so if we were to do the idea of identifying the positions, in this case we can see it's going to be the 5 buses. And the objects, in this case, if you take a look, we actually don't know. So let's keep that at X. Okay, so a certain number of people had to be transported in 5 buses. So we don't know how many there are. But if, let's simulate this actually. Let's say we had 6 people. 1, 2, 3, 4, 5, 6. Keeping the number of people on a minimum would mean that we would never put all 6 people onto one bus, because that wouldn't be keeping number of people on each bus a minimum. Okay, so we would divide them like so. We would put one on one bus, the next one on the other, and so on like this. Okay, and there we go. So it'd be like that. So we would try and distribute them as equally as we could onto each of the buses. Now, it says that at least one of the buses had 33 people on them. Okay, so let's say that there were 33 people here. Actually, let's go back to this simulation. Now take a look. After this 5th person, we took this last one and placed it here. So look at the object. So look at the order. Place one here, place one here, 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 then here. Then for the 6th person, we have to go back to this one. Okay, so if we were to think about this with the 33rd person, the 33rd person goes on to here, which must mean that before this 33rd person was placed here, each of the buses already had 32, like so. But because we had to place another person here, this one bus is now up to 33. So, take a look. At least one of the buses had 33 people on them. Okay, so the minimum that we could have is going to be 4 times 32 plus 33. So calculating this, 44 times 32 plus 33, that's 161 people. Okay, and if it said at least one of the buses had 33 people on them, okay, what is the total number of people transported? Well, what if all of them had 33 people? Okay, because it clearly states that only at least one of the buses. So this here is the minimum number of people. And the most is going to be the 5 buses times 33, which I believe is going to be 165. So the range of people, so the total is less than or equal to 165, but greater than or equal to 161. So we don't know exactly how many people there are, but it's between 161 and 165 people. All right, so I hope that gave you an insight into this idea of the pigeonhole principle. Yeah, hope to see you in the next video and the final example on this generalized pigeonhole principle. Hope to see you then. Best of luck.